I am Afraz. Today I will be explaining about what are laws of mass action. What is laws of mass action? Laws of mass action was found by Goldberg and Weig in 1864. It states that the stoichiometric coefficient of a reactant or product should be made to its power. And where are laws of mass action used? Laws of mass action is used to find Kp and Kc's value. Kp means partial pressure exerted by two or more molecules of gas in a closed container, and Kc means which is also used to find the value of Kp. Now, I will show you what are the factors affecting loss of mass action and which are the factors that does not affect loss of mass action. Now, let me just share my screen. Loss of mass action. Understanding factors affecting the equilibrium constant. It was proposed by Goldberg and Weig. The rate of chemical reaction is directly proportional to the product of the concentrations of the reactants, each raised to the power equal to stoichiometric coefficient. Now I'll write and show you. If we have two products, product number one reactant and one product. So A plus B. Now I'll write a coefficient. I'll write 2 and here 3. So, and if I do it here, and the product side is C plus D. What happens here is here 2 and here 4. It will be this one. A plus E C plus the coefficient. So the coefficient of A is 3 and the B's coefficient is 4. For C there is no coefficient. So we will consider it as 1 and for D it is 5. Now what happens here is the Kc formula, we can write the Kc formula is products by reactants and we can write it as C square bracket since and the coefficient will go to power 1 will go to power, so we can just leave it as it is. And for D, we can make it as D square bracket D concentration 5, power of 5. So as you can see here, the stoichiometric coefficient goes to the power and same for the reactant side. A power 3 and B power. So this is how we write this is how stoichiometric coefficient go into the power. And next, it it forms the basis of the equilibrium constant expression. So this is the equilibrium constant expression. So the variable's coefficient will go to the power and Kc's formula is products by reactants. Now we will move on to the factors affecting the equilibrium constant. First we will learn what is equilibrium constant. Equilibrium constants for reaction A plus B is equal to this equilibrium. So it's forward reaction and backward reaction. So as you can see here, in this place I wrote 3 and in this place I wrote 4 last sum, and this place I leave it as it is, so it indicates 1, and this place I wrote 4 5. So I have give coefficients, without coefficients they give, and they give it as a variable. The equilibrium constant is defined as K is equal to C square brackets, which is C concentration power this C, and D concentration power the coefficient, stoichiometric coefficient, divided by A concentration, stoichiometric coefficient of A, and B concentration, stoichiometric coefficient of B. And K indicates that the extent of the reaction at equilibrium. Factors affecting equilibrium constant. The first factor affecting is temperature. Temperature for exothermic reaction increases. If the temperature increases, the K value will be decreasing, and for endothermic reaction, increase in temperature will make the K also increase. Now, nature of the reaction. Different reactions have different equilibrium constants. And example reaction. So, N2, which is nitrogen molecule, gas, and 3H2, which is also gas, gives 2NH3. This is an reversible reaction which can attain equilibrium, and this, so as I told, if the coefficient will go as power here, and this coefficient will go as power for the H2, and since there is no coefficient, we can put the power as 1 for this one. Factors that do not affect equilibrium constant. Concentration of reactants or product doesn't affect the equilibrium constant. Pressure, except when gases are involved in unequal moles, but still K remains constant. So when there is a gas and we apply pressure, the volume of gas will decrease. When the volume decreases, the formula there will be volume for finding the mass action. So if the mass action change, the law of mass action will also change, which makes the equilibrium constant change. When there is gases included only, if there is pressure applied and there is gases included, the K value will change. And catalyst does not affect the reaction, but they only speed up the process to attain the equilibrium. Volume changes do not affect alter K, only equilibrium positions. In summary, law of mass action gives the basis for equilibrium constant expression. Temperature is the main factor that affects equilibrium constant. Concentration, pressure, catalyst, and volume do not affect K. Understanding these factors is crucial in chemical equilibrium studies. So today we have learned what is law of mass action and what are the factors affecting law of mass action and what are the factors that does not affect law of mass action. Thank you.